Last one I want to do is this ball bouncing problem. So it starts at 60 feet, rebounds to 7/9 of the height, okay? So what we want to do is, basically what's happening is the ball is going to rebound to 7/9 of its height each time. So that means that we're going to multiply 60 by 7/9 over and over and over again. So first the ball is going to be at a height of 60, and then it's going to rebound and be at a height of 60 times 5/7. And then it's going to be at a height of 60 times 5/7 squared. And we're just going to keep going and going and going. Multiply by 5/7 to infinity. All right? So we should take a sum because we want to add up the vertical distance. That's what one of the questions says, is add up the vertical distance the ball is traveling. So if we take a sum from n equals 1 to infinity, because we're just going to assume the ball is bouncing forever and ever and ever. It doesn't matter. It's converging to a certain value of 60 times 5/7. Not 5/7. That's the one on the Jeopardy question. This is 7/9. So, oh my God, I did 5/7 the whole time. 7/9, people. 7/9. Why didn't you tell me? 7/9. 5/7 is the Jeopardy question. Okay, 7/9 to the n minus 1. So what this tells us is we get 60 first because we plug in n equals 1, and 7/9 to the 0 is 1, so we get 60, plus 60 times 7/9, plus 60 times 7/9 squared, and we're going to go on forever and ever and ever. Now there's a problem though. The ball, here it is, it drops 60 feet. It rebounds to 60 times 7/9. But then it has to fall down again, right? It has to travel that distance twice. We're only counting that distance once. There it is. We have to count it twice, or we're not going to get the full vertical distance that the ball is traveling. So what we have to do is we have to multiply this sum by 2. And now it's going to count all the heights twice. Oh no, there's another problem. It doesn't travel 60 feet twice. It only travels 60 feet once. So what we're going to do at the end is we're just going to take our sum and we're just going to subtract one of those 60s. So now it doesn't count 60 twice. It only counts 60 once. It's going to count all the other heights twice, which is what we want. Okay, so now we just have to figure out how to sum this up. And how we sum it up is we use our infinite sum formula, which is the limit of our partial sum formula. So we get A1 is 60, that's our first term, over 1 minus R, 7/9. That's equal to 60 over 2/9, which is equal to 540 over 2. I just copied out flipped, right? Like that. And 540 over 2 is equal to 270. All right, and then we have to multiply that by 2, so we get 2 times 270. 270 is this whole thing, right? That's what that sum converges to. 2 times 270 minus 60, 540 minus 60, which is 480 feet. Final answer. Okay, so there is our full workload there. You can pause if you want to look at it really quick. All right, the other question is going to ask, how long does it take, how many bounces does it take until the ball reaches blank height, some height? Okay, so this question is a little bit easier, I think, as long as you know how to apply a logarithm. So for this one, we just need to know how high the ball is bouncing to. So we get 7/9. Okay, after one bounce, it's going to be 60 times 7/9. After 2 bounces, it's going to multiply by 7/9 twice. This is our expression. Let's say we want to know how long until the ball reaches 3 feet. How many bounces is it going to take till our ball reaches 3 feet? Well, to get this, we have to isolate our base so we can apply a log. So we get 7/9 over times 3 over 6, or is equal to 3 over 60. We divide it by 60 on both sides. We can simplify that as 1 over 20, I believe. Divide by 3, yep, okay. So then to solve this, we need to apply a log. Keep our base of 7/9, switch the rest. Okay, so we're going to do of 1/20 equals n. That's going to tell us the number of bounces. Let's find out how many bounces it takes. So there's a couple ways to do this. Change of base formula. We do log of 1 divided by 20 divided by log of 7 divided by 9. We get 11.9, or we can go hit the math button, scroll all the way down to log base. Okay, our base is 7 divided by 9. 1 divided by 20. Enter, we get the same answer. It's 11.9. That means after 11.9 bounces, we're at 3 feet. But we can't have 11.9 bounces. At 11 bounces, it's going to be a little bit higher than 3 feet. So we have to round this up and say that that's 12 bounces. And that is it. That is the bouncing ball problem.